Now, the velocity of a fluid element is given as v is equals to minus y square xi plus 2yx square j. At the point 1 by root 2 comma 1, we have to check whether it is rotational or compressible or incompressible and so on. Now, in order to find whether the fluid is compressible or rotational or irrotational or incompressible, we have to find dou v by dou x as well as dou u by dou y. And we know the value of v. V is nothing but dou v by dou x is nothing but 4xy. At the point dou v by dou x 1 by root 2 comma 1, it is nothing but 2 root 2. Similarly, dou u by dou y is nothing but minus 2xy. The first value is u and the second value is v. So dou u by dou x at the point 1 by root 2 comma 1 will give you minus root 2. Now, in order to check whether it is compressible or irrotational, first we'll find the rotational acceleration, which is nothing but omega z, which is half of dou v by dou x minus dou u by dou y. If we substitute, it is nothing but 1 by 2 into 2 root 2 plus root 2 at the point given. So which is nothing but greater than 0. If it is greater than 0, then the answer is rotational as well as compressible. Now we have to find the Laplace transform of the function e power at, where t is greater than 0 and a is a constant. Now it is a straightforward question and it's a direct formula. Laplace transform of e power at is nothing but 1 by s minus a. So option A is correct. Complex number is 2 times of 1 plus I, and we have to convert this into polar form. Now 2 plus I can be written as 2 into root 2 into 1 by root 2 plus I by root 2. It is nothing but multiplying dividing by root 2. So it can be written as 2 root 2 into 1 by root 2 can be written as cos pi by 4 plus 1 by root 2 can be also written as sin pi by 4, which is nothing but I sin pi by 4. Now 2 root 2 into, we know that cos theta plus I sin theta can be written as e power I theta in polar form. So this can be written as e power I theta is nothing but pi by 4. So the correct answer is option A. In Gauss elimination method, for solving linear algebraic equations, triangulation leads to what? Now, in Gauss elimination method, we'll convert the given augmented matrix of the form into the form 100 alpha, 010 beta, 001 gamma, which is nothing but a triangular matrix. So which is nothing but a diagonal matrix. So the answer is option A. Given function is f of x is equals to 1 plus 2 plus so on up to x. It is nothing but sum of first x natural numbers by 1 square plus 2 square plus so on up to x square, which is sum of squares of first x natural numbers into x power 4. Now we have to find the limit of this function when x is tending to infinity. So x is tending to infinity. We know that 1 plus 2 plus so on up to x is nothing but x into x plus 1 by 2 by, this is nothing but x into x plus 1 into 2x plus 1 by 6 into x to the power of 4, which can be written as limit x tends to infinity 3 by x cube into 2x plus 1. As x is tending to infinity, we know that 1 by x tends to 0. Therefore, limit x tends to infinity, f of x is nothing but 0, which is option B.
The data from the question that was given over here, it is at a point in a steel member, the major principal stress was given as major principal stress sigma 1 we will represent, it is given as 1000 kg per centimeter square, and the minor principal stress is compressive. The minor principal stress they have given it as compressive, so we consider the negative sign for this. Tension we can take it as positive. If the uniaxial tensile yield stress sig tau we can say is given as 1500 kg per centimeter square, then the magnitude of the minor principal stress, this minor principal stress we have to find out, at which the yield stress will come according to maximum shear stress theory. We know the maximum shear stress theory. From that we can say the uniaxial tensile strength divided by 2 is sigma 1 minus sigma 3 divided by 2. So here sigma 3 is tensile and this one is also tensile. Here it was given it as sigma 3 is as compressive. So sigma 1 minus of minus sigma 3 is divided by 2 is sigma 1 plus sigma 3 by 2 tau by 2. So tau is given as 1500, sigma 1 is 1000 plus sigma 3. Sigma 3 is equal to 500 kg per centimeter square compressive. So 500. Option A is correct. Question is, we have to find out the slope at the end of simply supported beam of span 2 meters and load of 5 kg per unit length over the entire span. So 5 kg per unit length. So we know the slope of a simply supported beam, that is theta is equal to W L cube by 24 EI. W is 5, L cube is 2 cube by 24 EI. E is modulus of velocity, I is moment of inertia. So 5 into 8 by 24 EI. That is equal to 5 by 3, 1 by EI. So option B is correct. Here the question is, find the vertical reaction at A from the following figure. So as it is a very simple question, so the figure is given as an UDL about 8 meters. The UDL is acting of 1 kilonewton per meter length. So if you take moments about point B, so if you consider RA is the reaction at A, RB is the reaction at B. So RA into 8 into 1, 8 plus 5, 8 plus 5 is equal to 1 into 8 into 4 plus 5 plus 0, RB into 0. That is equal to RA into 8 plus 5 is 13 is equal to 8 into 9 plus 0. That is equal to RA is equal to 8 into 9 by 13. That is equal to 5.54 kilonewtons. So option B is correct. A long and short span of a two-way slab is given by Ly and Lx, and the load on the slab acting on strip parallel to Lx and Ly are given as Wx and Wy respectively. According to the Rankine-Grashof theory, the relationship between the Wx load on the slab along the Lx and Ly short and long length of two-way slab is given as Wx by Wy is equal to Ly by Lx whole power 4. So option D is correct. Is something like, for a beam in rectangular